All right, congratulations. You guys are down to your last video. I'm sure you're excited to not hear my dog barking in the background or listen to my voice anymore, for a little while at least after today. So we're looking at Notes 4B, Operations with Scientific Notation. This time we're multiplying and dividing. So let's take a look at what's bolded right under the top heading of your paper. Numbers in scientific notation can be multiplied and divided directly by using properties of exponents. So what that's saying is if you go back to the first video you guys started listening to me explain to you, you can just use those properties and multiply and divide. This is much easier in my opinion than adding and subtracting. So let's read what it says about the sun. When the sun makes an orbit around the center of the Milky Way, it travels 2.025 times 10 to the 14th kilometers. The orbit takes 225 million years. At what rate does the sun travel? Write your answer in scientific notation, and here's your hint. Use what you know about calculating rate to solve this problem. That's a 2 right there. T-O, to solve this problem. Rate is equal to distance divided by time. So step 1, substitute the values from the problem into the rate formula. So rate is distance divided by time, so that's why your distance is up here and your time is down here. So we're dividing. And step 2 is write the expression for rate with years into scientific notation. So obviously you can't add or subtract or multiply or divide anything with this if one is in scientific notation and the other one is in standard notation. So we're going to have to take this big number and drop the decimal and go back 3, 6, 7, 8. And so that's where they came up with now 2.25 times 10 to the 8th years. So now that they are both in scientific notation, then we can easily divide. This is how to divide, and I love it. It's so simple. All you have to do is take your front numbers, your multipliers, and divide them. See how they did that right here? So they took 2.025 and just divided by 2.25. And that's 0.9. So hold on to that number for a minute. We'll come back to it. And then you look at your scientific notation numbers, 10 to the 14th divided by 10 to the 8th. And remember, if our bases are the same, when you divide exponents, all you have to do is subtract them. So 10 to the 14th divided by 10 to the 8th is actually whatever 14 minus 8 is. So right over here it's done for us, and you get 10 to the 6th. So put your front numbers that you divided together with your powers that you subtracted, and you have your final answer. 9. Oh, sorry, nope, just kidding. You have this answer to begin with, 0.9 times 10 to the 6th. The problem with that is, I hope you all know by now, it is not official scientific notation unless that front number is between 1 and 10. So in order to make it between 1 and 10, you are going to have to take your decimal and increase it to the right, which decreases your exponent by 1. So when you move that decimal over, now you have your final answer, 9, and now it's times 10 to the 5th. So this is your actual proper scientific notation final answer. Okay, let's look at our 2 examples that I'm going to do with you. So for multiplication, exactly like division, you're going to take your front numbers, your multipliers, and you're just going to multiply them together on your calculator. So mine says, after I put in, 3.48 times 5.2. My calculator says 18 point, there we go, 096. And I hope you remember from several videos ago that if you have numbers with the same base, when you're multiplying, you can just add their exponents. So you have a 4 and a 2. So 4 and 2 is 6. So it is times 10 to the 6th. Now, just when you think you're done, make sure your number is in proper scientific notation. Make sure that front number is between 1 and 10, and unfortunately it's not. So we are going to have to decrease the value of our number, which increases the exponent. So if we move it one place to the left, our exponent is going to increase by 1 number. So our final answer is going to be 1.8. 8096 times 10 to the 7th. Now it's between 1 and 10, so now you know you're done. All right, on the second example, remember you cannot do this unless they are both in scientific notation. So we're going to have to take this big number, 26 billion, and we're going to have to put it in scientific notation. So if we drop the decimal at the end and move it back 3, 6, 9, 10 places, that would be 2.6 times 10 to the, how many did we say? 3, 6, 9, 10. All right, now we can divide, like it said, these two numbers. All right, when you divide, take your front numbers and just divide. Just put them in your calculator. So I'm going to put that in my calculator, and it says 4.94 divided by 2.6. My calculator's answer says 1.9, and I'm already loving this answer because 1.9 is already in proper scientific notation. And then we're going to have a times 10 to the something. And remember, if we're dividing and the numbers have the same base, that's like putting a 10 to the 13th here, dividing by a 10 to the 10th here. Anytime the numbers have the same base, you may subtract their exponents. So is that a 15? Oh, that looks like a 15. Sorry, that is a 13. 13 minus 10 is 3, so 10 to the third. And that one is now done. Okay, take a minute, pause the video, go ahead and try 3 and 4 your turn, and then come back and check for the correct answer. Okay, so check your answers. Part 1, what you should have done, which is number 3, is you should have taken 4, or 4.0, and multiplied by 3.65. So in my calculator, 4.0 times 3.65 is 14.6. And 10 to the 7th times 10 to the 2nd would be 10 to the 9th. But that's not your final answer because this is not between 1 and 10. So if I move it back one place and make it smaller, it is going to make my exponent larger. So the final answer would be 1.46 times 10 to the 10th. All right, on number 4, first you have to make this number scientific notation. That should be 3.67 times 10 to the 9th. So in order to divide, take your front numbers and divide them. 1.17 divided by 3.67, and that equals 0.318800109. And then when you take a times 10 to the 7th divided by 10 to the 9th, you are going to get some negative number, and that actually is no good. So we are going to change this last number, and I'm just now making that decision. So I'm so sorry if you did the your turn. Let's flip-flop these just for fun. That was circled, that one's fine. Let's say this number divided by this number. So again, we have 3. Just bear with me, I'm so sorry guys, 67 times 10 to the 9. And instead we're going to divide by this guy. Sorry, you guys are going to have to erase, but just deal with it. Go with it. At least you're not listening to the boring guy in Khan Academy. Get over it. Alright, 3.67 divided by, I like this number a lot better, 3.67 divided by 1.17 is still a really gross big number, but it's okay. 3.136752114. If I put that in right, let me just double check. 3.67 divided by 1.17. Yep, that's what I got again. Double check it on your calculator. Okay, however, 10 to the 9th divided by 10 to the 7th is nice and neat because 9 minus 7 is 2. So times 10 to the 2 to the second. And what's beautiful about this now is it's already in scientific notation because 3 does fall between 1 and 10. So you are done. Sorry about the little flip-flop. Nice work.